Yes, your model is generalized, and no, your model is not generalized.
Right, because it's always a point in time, right? Because the world is not static, and therefore there's always a need to keep improving your models, right?
Welcome to Practical AI, everybody. This is our second season. We are sponsored by Pocket AI. Pocket AI is a tool used to perform surgery on your models to make them better. While everyone today is talking about RAG and refinement, Pocket AI allows you to edit your weights of your model directly. Peter, you were going to help us today just understand how to make an ML data set.
Yeah.
Tell us a little bit about how you would do that.
So there's a lot of different ways, but the easiest one is to actually just start by creating an image data set. So I'm just going to share my screen. There's a free tool, or actually a free website called Roboflow, which is pretty cool. If you go to roboflow.com, you'll see kind of their homepage. It has a nice little animation about like, oh, this is computer vision recognizing things. So if we go into my personal account, here I have a couple different like data sets that I created for fun. So one is tomato. And basically what you do is you can take photos, you can upload them, and then you can define classes. So if I go to the left here, so in this case, I have three classes. I have tomato, tomato flower, and not tomato. And if I go to the data set, we can see. So for example, if I click on one of these images, you can see that I've drawn a box around the tomatoes. And I can scroll through. On the left, you can see the labels. If I move my mouse over, it'll highlight it. If I scroll, for example, I can go to one with a flower. So if I go to flower, you'll notice it highlights it. And so the idea is you take photos, you upload them, and then once it's uploaded, you can draw a rectangle around the thing in the photo. And usually, for example, like this picture actually has a couple more tomatoes that are hidden behind a leaf. And in this case, I didn't draw a box around it because there's probably not enough information there. So that would actually make the training do worse because it's just a tiny little bit of a tomato. Whereas these other ones, it's got pretty much more than half of the actual tomato fruit. And it's also kind of good to have kind of different shapes, different sizes, different kind of orientations. If we go through, you see more.
These are all pictures you took yourself, Peter.
Yep. So these are tomatoes from a few years ago, I think back in 2021. And so I was growing tomatoes, and I thought, well, I know what, I'm growing tomatoes, so I can use it to take photos. And every week I would go out and take pictures because, as you can see, like, like some were green and some were yellow. And as the season progressed, the color of the tomatoes would change as it ripened. Right. So like here I have a yellow one and a red one. And in general, when you create the data set, you want to make sure you have a diverse set of examples, because if we were to only have like green colored tomatoes, right, like these ones, if you gave it a red tomato, it would not see it. It'd be like, that's not a tomato. And in general, you just want it to be as diverse as possible and as close to reality as possible, meaning that what it'll see in the real world is a good approximation of what the program will need to be able to recognize.
Okay, so in computer vision, then, if we're training a model, we need these images, right? And so the images are in the data set. And so you'll take that data set then. So you have 50 total in your thing. And if you're going to train, using Pocket AI, for example, on a tiny data set, you would take that 50 and you'd divide it, right? You'd have a training data set and you'd have a test data set, correct?
Yeah, so what you do is, so first you create the data set. So if you go back to the top, what you can do is when you create a data set, you can actually save it for multiple versions. So for example, if I come into, so I have a total of 402, and then I can go to versions. And so when you create each version, you can give it kind of the breakdown for the training, validation, and the test. And so this is kind of configurable. When you create a version of it, you can decide what the breakdown is. And if you want, so for example, like I can come in here and see, where's the button for create new version? Here. So you go to versions, you go create new version. And here, so this is kind of nice. You can do pre-processing steps. So for example, you can do kind of auto orient, you can isolate, you can statically crop the image, or you can dynamically crop the image. You could grayscale, you can adjust the contrast, or you can resize, you can do like basic image augmentation to give you a simple way to make your data set bigger.
Okay, so the pre-processing or augmentation you're talking about, that gets your, I think your data set originally had 402, but when you clicked somewhere else, there was over 900. Is this because you had done some augmentation and pre-processing already?
Exactly. So for example, this one, I apply some image augmentation to get 964.
Okay, so you might have taken one of your images of a tomato and just simply rotated it 90 degrees or something like that.
You
Okay.
can flip vertically or horizontally, or you can have it just crop like 10% in.
Okay. So there's a
And so
way
that,
for you to extend a small data set and get more out of it, essentially.
right, because so the idea is that you want to give it a diverse selection of images to train on, right? Because it's not like if I were to take this and put it on a phone, I'm never gonna take a picture exactly at the same size as this image, right? Like I'm not gonna frame it exactly this way every time. And so you want to give it kind of different sizes of images where the tomato takes up the whole entire thing, or just a small portion of the image, right? So like it's good to have a wide variety of kind of, so you'll see like here, this is upside down.
Yeah.
This was done by the image augmentation. It just flipped it. And if we scroll through, we can see it kind of flipped a lot of them upside down. And then also flip some right to left in a mirror image.
Okay, so if you are going to train then, it seems like you could probably get this thing to recognize a tomato versus a non-tomato, right? A human or whatever. Maybe not a ball, but pretty quickly you could get it to learn a tomato. But how do you get it to do then like a Roma tomato?
So then you would come in here, instead of just tomato, you would put in the actual variety. So you might put in a black prince, a Roma, um, you might put in a cherry tomato, you might put in a purple Cherokee. So you would basically go and find as many varieties of tomatoes as you can, or ask others to get it to you. And then you would just create those labels and then go back to your image. And now instead of, so like here, this one, these are cherry tomatoes with I think that's an heirloom, that might be a purple Cherokee. And so now instead of tomato, you would come in here and say, this is a purple Cherokee tomato. Whereas like this one, I think it's, get the name of the variety, but this was just one variety. And this was some kind of a small, it's called something yellow, I forget. So you would come in here and actually give it the label for that variety of tomato.
Okay, so when the model, like, so let's see, now you've trained and trained and trained, and it's gotten really good. If it's generalized, it will be able to recognize any tomato, but only any tomato that it's been trained on, right?
Right. So here's the catch, right? So like tomatoes is one of the plants where growers are constantly crossbreeding and getting new varieties. So let's say I've trained it on 30 varieties. And let's say, for example, purple Cherokee is a really popular one because it's got this like purple color. I think this was a small one. That's a purple Cherokee. And so if someone were to crossbreed purple Cherokee with a beefsteak, right? And it looks similar to the purple Cherokee, when you use the model, it might confuse it as a purple Cherokee because it looks similar. Right? Because what they'll do is it'll try to find the closest thing in its classes that it's been trained on, and then it'll just assume that it's that thing.
Okay, so let me ask maybe a technical stupid question, but if I create a model off of 30 varieties of tomatoes, and it can get 100% of the time, it can nail those 30.
Yeah.
Do I have a generalized model? I'm just focusing on the word generalized. Or because you could create a 31st version of a tomato, is it not generalized?
So that's a great question. So from an engineer's perspective, it's generalized for the 30 classes you've trained it on. If next year someone comes up with 8 new varieties, then it's probably not generalized for those 8 new varieties. Right? Because like it might be able to say, okay, this looks kind of like a beefsteak. So, and it might be a crossbreed between a beefsteak and some other variety. And if it said that it's 80% likely to be a beefsteak tomato, it's not wrong because it was crossbred. But at the same time, if you're a person that's looking at a tomato and trying to figure out, like, okay, what is it in my yard? Like, I can't tell. And you have a beefsteak and you have another variety that's a crossbreed, you want to know exactly which one it is, they would have to retrain it with the labels for this new variety.
Okay, so essentially generalization is as a word, like a lot of things, it's a word with layers of meanings to it. Yes, your model is generalized, and no, your model is not generalized.
Right, because it's always a point in time, right? Because the world is not static, and therefore there's always a need to keep improving your models, right? Because even if someone were to train a model that recognizes 100 varieties of tomatoes today, 5 years from now, there may be like 80 new varieties, which is great from a eating and cooking perspective. But
Yeah.
from your model perspective, your model's out of date now.
Right. And models are never going to be able to just pivot and learn that way. They have to be retrained with the new, in this case, images, but in the future case, prompts and what else.
Yeah, exactly.
This is awesome, Peter. Well, it looks like a cool tool, and for people that are getting into computer vision, that seems like an easy pathway to get in, and an easy road to generalization. Although it's a long way to go once you get your data set built, right? You got a long way to go. But thank you, Peter. This is super helpful, and please like, comment, subscribe. We will try to give you topics that are interesting. In the meantime, we'll see you next week. Take care, everybody.